Okay, now as I was just saying, we have to stop this about every 10 minutes just for the upload. Anyway, so chloride ion. What's the oxidation state on chloride ion? -1 because chloride has a -1 charge. Okay? What about this one? What do you say, McKay? +3. That's true. And what about the chlorine here? 0 because it's a pure element. All right. So we need to ask ourselves these questions. What is oxidized? In other words, what has its charge being increased? Chloride ion. Okay? Okay? We're going to leave a blank space here because we're going to write something else in here in a moment. What is being reduced? What's being reduced here? Well, chromium ion is the result of it. What's being reduced? Which piece of these is being reduced? The dichromate ion. Cr2O7, 2-. That's what's being reduced. Okay? Knowing this information, let's write a half reaction for each of these. Okay? And in a half reaction, all we're worrying about is just getting from beginning to end. We've got to balance it by mass and by charge, but we don't have to balance it with respect to the other stuff. Okay? So, what's our half reaction for oxidization? For the oxidation reaction? Cl- being reduced to Cl2. We've got to put a 2 in front of that just to balance it by mass. Okay? Now, half reaction for this one. Cr2O7, 2-, is being reduced to Cr3+. Again, let's put 2 in front of there. Now, what about the oxygen? Well, the short answer is we're going to get to that. Okay. But if we have these two half reactions, we can use these as a place to start to solve the overall balancing of the reaction. Are you with me so far? Yes?
So the chromium on the reduced half reaction, when you balance it with 2,
Yep.
that's ignoring the oxygen 2-.
For right now, yes. For right now, we're ignoring the chromium, the oxygen.
Alright.
We will account for that momentarily.
So the chromium 2 on dichromate, didn't you say that had a +6 charge for each one?
Yes.
So when you balance the chromium 3+, because isn't that just 6+ for the entire chromium?
Yeah, but then you have all these negatives.
Oh, so you just leave that.
We're not there yet, but it's good that you're thinking that way because that's the next thing we have to deal with. How do we change the charge from a +6 here to a +3 here? Okay? That's the next thing we're going to talk about. All right? Everybody got what they need from here? All right. Please take very good notes this next couple of pages, because this will be your Rosetta Stone or Urim and Thummim, or however you want to express it, for solving these problems. Okay?
Don't hold such thing.
Sorry. Strike me down. All right.
Don't think you could say that one either. Unless you're you were referring to the superintendent.
Well, you never know. Okay, so to solve this, we're going to look at 5 relatively easy steps for balancing an oxidation reduction reaction. A couple of which you already know. One of which we just did, in fact. Step number 1, identify the oxidation and reduction and write half reactions. Identify what is oxidized and reduced and write half reactions. Okay? For once, the first step in solving the problem is not to write a balanced chemical reaction.
So this is the exception.
This whole process is about how you write the balanced chemical equation for something like this.
Well, yeah, technically, this whole process.
This whole process
finding the
gives you the end result of a balanced chemical reaction, yes. Okay? You with me so far? Second step, which we haven't done yet, but we'll do in a moment. The second step is to balance each half reaction. And the steps you use in this step, sub-steps, are like this. A, balance all elements besides hydrogen and oxygen. And if I say by mass, you know what that means, right? Same number of chromium on one side as you have on the other side. Balanced by mass. Okay? Sub-step B. Balance oxygen by adding water. Yes, Mikkel?
Is that why we ignored oxygen earlier?
Yes. Balance oxygen by adding H2O. So if you've got oxygens unaccounted for on the left side of an equation, say, you'll add water on the right side of the equation in the appropriate amounts until you have the same number of oxygen on both sides. Now, by doing that, you're of course adding hydrogen. Because if you add water, not only you're adding oxygen, you're adding hydrogen too. So that's sub-step C. Balance hydrogen by adding hydrogen ion, H+. Okay? Of course, by adding H+, now you're introducing charge. So the final sub-step, sub-step D, is to balance charge by adding, you ready for this? Balance charge by adding electrons. Now you're probably thinking, can we just add electrons? Well, yeah, for now. Okay, so when you're done with this half reaction, you're going to end up with the same number of all the other elements besides hydrogen and oxygen on both sides, the same number of hydrogens on both sides, same number of oxygens on both sides, and the same charge on both sides, due to presence of existing ions, H plus, and electrons.